Okay, welcome to this video on solving systems of three equations with three variables. The methods we're going to use in solving this are the graphing method and the elimination method. Since graphing has been a little more familiar to us as of late, we'll start with that one first. Again, when you're trying to graph a 3D equation on the system here, we want to make sure we find the intercepts. So to find intercepts, we want to try to put 0 in for the opposite two letters. So if I want to find the x-intercept, I'll put 0 here and 0 here, and essentially take 12 divided by 3, and I'll get 4. Do the same thing for the y. I'll have 3, and the same thing for the z, I'll get 2. So I'll have x-intercept of 4, a y-intercept of 3, and a z-intercept of 2, put them on the coordinate system, and then create a triangle. That triangle then represents the plane of the first equation. Then I do the same thing for the middle equation here, finding x, y, and z intercepts. They'll be 3, 3, and 3. Plotting those points creates another triangle. What you'll notice about the two planes is they both share the point 3 on the y-axis, but they also then cross and share a point right here in this location as well. And that becomes your line solution between the two planes that are non-parallel. So then I have this as my solution for the first two planes, or the first two equations essentially, graphically. Then I take the third equation, plot it by its intercepts, and I'll take and put negative 12 divided by negative 3, that'll give you a positive 4, and put 12 divided by negative 4, or negative 12 divided by 4, and I'll have negative 6, and so on. Then I'll have my intercepts at 4, negative 3, and 2. Well, in order to plot a negative y-intercept, I need to make sure I make a negative y-axis, which is the y-prime axis. Then I'll place those points down, and then I'll have a solution that I'll see here as well. Between the red and the green planes that you see here, which is the first and the last one, you'll see that they also share a solution or a line in common. Now that line is going to then share one coordinate in common with the first one that we had between the blue and the red. That one coordinate is special because that's the place you're going to find the solution. Now, if I want to try to figure out where's that point in space, well, if I count from the origin, it's 2 over in the x direction. I don't go anywhere left or right in the y direction, but I do go straight up from there to get to this location. So I'm going 2, 0, and then 1, and that becomes my solution to this system graphically. Now, the next thing I need to do is think about how I solve this with elimination. So let's go there next. The strategy that you want to be thinking about is trying to find a pair of equations that you can then put together and then cancel one letter. So let's say I were thinking about canceling these two equations together. Well, then I would simply multiply the top equation by 2 to get rid of the z's, and that'd be pretty easy. Then I would just add the x's and these last numbers here and get a new equation with x and y in it. And now I would do the same thing on a new pair of equations. Let's say I chose these two. Well, this kind of works out nice, and then let's say again I want to cancel out the z's and I get it down to another equation with x and y. But another way to consider is you can also take it like this. This won't work so well because I don't have opposites. But then also think about this. If I were to go one step further, you can put these in any combination of pairings that you want. Just make sure you have two different pairs of equations. This is a good idea or strategy in this one because you'll have a positive z term and a negative z term. And then also for the blue one, you'll have a negative z term and a positive z term that we can also cancel. And like I said, you'll get it down to two equations with two variables, x and y. And then take that xy equation like you did in Algebra 1 and get it down to one variable. Solve for that one variable. You'll take that one answer you solve for, put it back into either one of these two equations here, get the second variable answer, and then you'll take both of those answers and put them into any one of these original three equations and then find the last missing variable. Once you have all three of those variables figured out, you'll then express your answer as a coordinate. Okay? Let's go back to the one we were just working on here and see if we can get this one worked out. So let's say we pair them up in a way so that we get a positive and negative. And if you notice what I have in blue here, I have a negative 6 and a positive 6. And I also have with the orange ones here, I have a negative number here and a positive number here. It just so happens to be that those happen, you can pair them up however you want, but it's nice to try to look for terms where you have a positive and negative. Now if I'm looking at the z's here, and I do that, I would then add these two equations together. So I'm just taking this equation here and this equation right here, and then I'm just going to add them together. Since I already have a positive 6 and a negative 6, okay? Adding those together, what's kind of cool is that all three of these things cross out, leaving with just 8y equals 0, because I have a 0 over here. Then when I solve for y, I'll have y equals 0. I've got one of my variables already. Now, I need to try to find a new pairing of equations. I've used the first and the second together. If I wanted to, I could combine those two or these two. Let's just say I chose the bottom two. And if I was going to combine these together, I would want to try to cancel the z's as well. So to get the z's out of here, I have to multiply the top equation by 6. Okay, so if I do that, then the new top equation then will turn into what you see down here as 6x plus 6y plus 6z equals 18. Then, keeping the same bottom equation the way it was, I add those together. what happens is that the z's will cross out, and then I end up getting the equation 3x plus 10y equals 6. So now that I've brought this down now to just an equation with two variables, I can take my solution from up here and then substitute it in for y down here. Well, then 10 times 0 is going to just make 0 here. So I have 3x equals 6. And if 3x equals 6, then x has to equal 2. Now I've taken this system down to two variables, and now I want to take these two variables and go back to the original equations. Let's just say this one because it's very easy, and solve for x, y, and z, or solve for the missing letter that I don't have, which is the z value. So I'm going to go back there and I'm going to put the 0 in for y, the 2 in for x, and solve for z. Doing so, then z has to equal 1. And now I have my solution, 2, 0, 1. Hopefully you're starting to see the strategy then, as it's about combining equations with canceling and then multiplying if need be to cancel a letter out, and breaking it down to two equations and then getting it down to 1. Now take this system that we kind of demonstrated earlier with the strategies and see if you can solve it algebraically and graphically on the piece of paper. So take some time to download and print out the paper copy of this problem, solve it graphing, like I said, in elimination, and then submit your answer when you're done. Thanks for watching this video, and hopefully it helps.